Looking at the formula, we can tell a lot of information about the hyperbola. With the Q value, we shift up if this is a positive and down if it's negative. And with the P value, we shift left for positive and right for negative. Remember that the A value tells you the shape. If it's positive, we have top right and bottom left, and if it's negative, we have top left and bottom right. Your P and Q values also give you the asymptotes. We have the line y equals q for the horizontal asymptote, and we have the line x equals negative p for the vertical asymptote. When you're sketching hyperbolas, start with the asymptotes. You can read those straight off the formula. Make sure that you have a little sketch of the shape so that you know more or less what it's supposed to look like. Get the intercepts, y-intercept by letting x equals 0, and write down the point 0 with whatever you get out as the y value. To get the x-intercept, you're going to let y equals 0. You're solving for x, and then you're going to write down the point where x is a number and y is 0. The axes of symmetry are slightly more complicated than the grade 10 graphs because they intersect at the point negative p and q, which is the same place as the two asymptotes intersect. Remember that these are essentially straight lines, and if you need to plot them, you've got to plot their y-intercepts as well. You can get that by subbing in the gradients that you've memorized. So for the positive one, it is a gradient of 1, and for the negative one, it is a gradient of negative 1. When you sub those in as well as the point of intersection, which is your negative p and q, then you're going to get out ordinary straight line formulas with a c value that tells you the intercept on the axes. Drawing the graph, you're probably going to need more than just the asymptotes and the axes of symmetry and the intercepts, because to get the shape, you're going to need a few extra points. If I just put in the axes of symmetry here, and if I put in the intercepts with the axes, then I don't get a full enough shape. So I'm going to plug in a few more numbers to get a general shape, and you need to do as many as you can to get the right shape. So whatever you need, that's what you need to plot in. Reminder that these cross at the same place as those do, and that point of intersection is really useful for finding the equation of the axes of symmetry. Remember to label every one of your points as well as the graphs, and if requested, the axes of symmetry as straight lines as well. When we're getting information from the graph, it normally follows these. Domain and range, you're going to have anything except each of the asymptotes. When we look at increasing or decreasing, remember that these graphs will either increase for all values except the asymptote or decrease for all values except the asymptote. When a is a positive number, it's decreasing, and when a is a negative number, you have increasing graphs for all values except the asymptotes. The transformations we look at are either reflections or shifts. Reflections in the x-axis means that you are going to make the y value negative. So you're going to apply the negative to the f of x, which implies that everything else needs to get multiplied through by negative 1. When you reflect in the y-axis, the x becomes negative. So there, x gets the negative, and when you plug it in and tidy up the equation, you can see you need to move it to the top, which again changes the position of the hyperbola. When we are shifting up and down, remember that you're just adding or subtracting numbers onto the end of the equation. But when you're shifting left or right, remember that plus goes to the left and minus goes to the right. When you write that in functional notation, it's going to go inside the brackets. So if you are adding 5 and you're shifting to the left by 5 units, that x plus 5 is going to happen where x used to be. Tidying up the equation, you can see it's changed quite a bit. Finally, finding the equation, you will normally be given the asymptotes that you can sub in for q and p. Remember to change the sign with a p, and then you're going to get possibly a point to sub in. Remember that you can use any intercept as a point if you just rewrite it as a point with 0 in place of x or y. Remember that the axes of symmetry cross each other, and they also cut the asymptotes at the point negative p and q, and that can be used as a point to sub into the equations for straight lines for the two axes of symmetry.